Hello and welcome to another Science Revision video. Now in this video we'll look at atomic number, mass number and what we call isotopes. So let's begin, shall we? Let's look first of all at atomic mass and mass number. Now every element, all 110 or whatever, how many there are, have got two numbers attached to them. This is the symbol first of all. Now this is symbol for sodium. It's a bit odd, isn't it? You thought it might be SO or something. No, this is Na. The symbol for sodium is Na. Now there are always two numbers attached to these. There's a big one, like this one, 23 here, and 11 here. Now what are they? Well, first of all, the 23 is the mass number. Okay, mass number. And this tells us the total number of protons and neutrons. Down here we've got the atomic number, and this is a number of protons. It also tells us how many electrons there are as well, which we'll come on to in a second. Now most textbooks, most periodic tables have them this way around. In a few textbooks and a few periodic tables, for some reason unknown to me, they actually put these the other way around, which is a little bit confusing, isn't it? Make sure though you always remember this one is the bigger one's a mass number, small atomic number. Now we can work out number of neutrons by subtracting these two figures here. You want to work out how many neutrons there are in sodium, you subtract 11 from 23. So, forgot about this bit. The mass number is always bigger than the atomic number. Always. Has to be, because there's neutrons here. Okay? Just realised that's not quite true. For hydrogen, it's 1 and 1, but that's just one exception. Okay? Now for sodium, we can work out how many protons, electrons and neutrons it's got. Now this number here tells us it's got 11 protons. This number here also tells us it's got 11 electrons. And the difference between these two gives us number of neutrons. So 23 minus 11, think about it, yep, 12, there we go. So 11 protons, 11 electrons and 11 neutrons. Got it? Right, very easy. Okay, so what's this thing called an isotope? Now isotopes shouldn't confuse us, so we just remember this basic definition. Isotopes are different atomic forms of the same elements. Okay, they've got the same number of protons and also electrons. All that differs is the number of neutrons they've got. Do you want an example? Here's one. There are two common forms of carbon. Looking at the periodic table, you'll see carbon is written down as C, 6 and 12. Here's a mass number, atomic number. We know it's got 6 protons, it's got 6 electrons. The difference between these two, 6 neutrons. But there's a second form of carbon called carbon-14. This is a radioactive carbon form used in carbon dating. Now here, look, same number of protons, 6, same number 6, but neutrons is a difference. So 14 minus 6, you don't need a calculator for that, is 8. Okay, so those are two isotopes. The thing about isotopes is the chemical properties are the same. These two same chemical properties, of course different number of neutrons in the nucleus doesn't affect the chemical behaviour at all. That's what we call isotopes. Now what is this term you might see in some books called relative atomic mass? If you look at definition in a textbook, you find it's a mass of a particular atom compared to the mass of an atom of hydrogen. Now I do not want you getting confused. It's the same as the mass number. So relative atomic mass is the same as mass number. So please do not get confused. If you look at your periodic table, you find that sometimes there's some odd atomic masses. 35.5. How can you have 35.5? Well, this all goes back to our old question about isotopes. Okay? Chlorine has got two common isotopes. Here they are. There's chlorine 1735 and chlorine 1737. Now, naturally, they are found in the ratio of 3 of these to every one of those. So, work out the average. We've got 3 of these, 35 plus 35 plus 35, 37, divided by 4, and you come to the answer 35.5. That is why in the periodic table it is shown as 35.5. Okay? It's that simple. Right, a lot of information so far. So where do we find relative atomic mass, atomic number of element, and so calculate protons, neutrons, and electrons? Where are we going to find this information? Where should we look? You've got it, periodic table, and we're looking at this in another video. Okay, so thanks for watching this video. Hope you found it all interesting and informative, and for more free videos visit my site at www.sciencerevisionvideo.com. Okay, I'm back with it again very soon.